Alright, so we're working on 41B. Now this 41 problem is two problems in one. It says calculate the number of grams of each reactant. So I have two reactants, that one and that one. So I got to calculate them separately. So I'm going to calculate this guy first. The problem says I'm starting off with 4 moles of methanol. Okay, so I don't want those moles of methanol. So I'm going to take my units, put them down here. And what can I change it to? Well, I'm looking for grams of a different thing. I'm looking for grams of this. So I got to get out of this chemical and into this one. So to change from one chemical to another requires a mole-to-mole ratio. And where do my numbers come from? Well, they come from my equation. There's no number in front of here, so that means it's a 1. And then I go from CO, I look up here, there's no number in front, so that's a 1. So it's a 1-to-1 ratio. I'm going to cancel off my things that are alike. So now I'm in CO. I'm in the right chemical. But the question says calculate the grams of my reactant. So I need the grams of CO. So I got to go another step. So I'm going to take my given here, the stuff I don't want, put it up here. Now what can I change moles to? Well, I can always change moles to grams. It's always the same chemical, moles to grams. It's always 1 mole. Carbon is 12 grams. I get that from the periodic table. Oxygen is 16 grams. And I add them up. And that's my molar mass. I cross off my like units. I'm in grams of CO. So I'm done. I just need to multiply that across. 4 times 28. Okay, that's my grams of CO. The question said how many grams of each reactant, so now I have to do the grams of H2. So here's 41B, continued. Now I want to find out the grams of this stuff. And again, I'm going to start off with 4 moles of methanol. I don't want any methanol. So whatever I start with unit-wise, I put on the bottom. And I want to change to a different chemical. I want to get to hydrogen. So this is the time to do that. I can always go from one chemical to another. That's a mole-to-mole ratio. Now my numbers, I look for this up here. There's no number in front. That means it's 1. There's a 2 in front of this guy, so he goes there. I'm going to cross off my like units. Well, I'm in moles of H2, but the problem asks for grams of H2, so I got to keep going. So I'm going to take whatever was on the last step, put it down there. Now I can always go grams to moles or moles to grams. When I go moles to grams, that's molar mass. It's the mass of 1 mole. I go to the periodic table. Hydrogen is 1 gram. I have 2 of them, so I have 2 grams of H2. Cross off my like units. I'm in grams of H2. The question said how many grams of reactants, so I know I'm done. I multiply straight across. So I have 16 grams of hydrogen. (41C) says I'm going to start off with 2.85 moles of carbon monoxide. Mono meaning 1, carbon meaning carbon. Alright, so even before I look at the problem, I know I don't want moles of CO, so I'm going to put it down there. Now we're looking for grams of hydrogen. So if I have a different chemical, I got to get out of CO and into hydrogen. So that means a mole-to-mole ratio. And I get my formula right from there. So what ratio do those work in? Well, it tells me I have 2 moles of hydrogen for every 1 mole of CO. No number in front means it's 1. So there's my mole-to-mole ratio. I'm just translating this equation into a fraction. Alright, I don't want this anymore. Those things cancel out. I'm in moles of hydrogen, but my question says, how many grams of hydrogen? So I got to keep going. So I take my units here, and I transfer them there. And I can always change moles to grams of the same chemical. It's always 1 mole. Hydrogen, I look on the periodic table, it's 1. There's 2 of them. 1 plus 1 is 2. And so I'm done. When I multiply that across, I know it's hydrogen because everything else is crossed off. All right, 42A. Says I have 66.6 grams of ammonia, NH3. And I'm looking for grams of F2. I want grams of this. All right, well, my first step, whatever's given to me, I got to get out of it. I got to get out of grams of NH3. I put it down there. I don't transfer the numbers. What can I change grams to? There's only one thing I can change grams to, and that's moles. And it has to be the same chemical. Okay, grams to moles is always 1 mole. How many grams? Well, I go to my periodic table. I have 1 nitrogen. And I have 3 hydrogens. I look up nitrogen on the periodic table. And I look up hydrogen on the periodic table. So 1 mole of ammonia has a mass, a weight of 17 grams. I'm going to cross off these units that are the same because they cancel out. They equal 1. So now I'm in moles of NH3. My question wants F2. It wants fluorine. So I got to get out of this NH3. So I'm going to take my given and put it down here. And on the top, I'm going to put the chemical I do want. A mole-to-mole ratio. Now to get my numbers, my coefficients, I go up here. F2 is 5, so F2 here is 5. NH3, I go up to NH3, it's 2. Cross off my like units. Now I'm in moles of F2. I don't want moles of F2, so I got to keep going. I'm going to take the units, put them down here. Now I do want grams of F2, and I can always convert grams or moles to grams and vice versa. Well, how many grams in a mole? Well, there's always 1 mole. I look up fluorine on the periodic table. It has a mass of 19, but there's 2 of them. So 1 mole is 38 grams. That's the molar mass of fluorine. Cross off my like units. I'm finished with grams of fluorine. The question says, what's the mass? What's the grams of fluorine? So I know I did it right. And I just have to do the math. Okay, so I'm going to take everything that's on the top. So I have 66.6 times 1 times 5 times 38. And on the bottom I have 17 times 2. If you're going to put all that in your calculator, make sure you use parentheses on the top and the bottom to separate those. If you don't use parentheses on the bottom, you're likely to get an incorrect answer. Alright, letter B, the 42B. Starting off with 4.65 grams of hydrogen fluoride, HF. Now I don't want that, so I'm going to put it down here. Now I can always change grams to moles. That's the only thing I can change grams to is moles. Now grams to moles is always 1 mole. And then what's the mass? Well, fluorine is 19. Hydrogen is 1. So I add those together. I have 20 grams for 1 mole. Well, these two things are the same, so I cross them off. Alright, I don't want moles of HF. I'm looking for a different chemical. So I'm going to take my units there and put them down here. Now let's see, what chemical am I looking for? I'm looking for NH3. So I'm going to put that on top. Going out of this chemical into this chemical. Now my ratio, HF, there's a 6 in front. NH3, there's a 2 in front. Okay, don't bother reducing that. That just leads to mistakes, and I want to check your work anyway, so I want to see that 2 over 6. It'll all work out in the end anyway. So I'm in moles of NH3. I go back to the question. Is that what I'm looking for? Nope. I'm looking for grams. So I got to keep going. Always go back to that question. Look it up. Once you get to that point where it's asking, you're done. Alright, so I need to go to grams. I got to go one more step. So grams of NH3. Moles to grams is molar mass. It's always 1 mole. What's the mass of this? Well, I go to my periodic table. I have 1 nitrogen and 3 hydrogens. I go to my periodic table, I look up nitrogen, and I look up hydrogen, and I add those together. 17 grams in 1 mole. Cross off my like units. So grams of NH3, double check the question, that's what it's asking for, so I'm done with that. Now I'm going to take all my numbers and summarize them. So I got 4.65, I have a 2 on the top, and I have a 17 on the top. I'll put that in parentheses when I calculator it, and on the bottom I have 20 times 6, and I'll put that in parentheses when I calculator it. And that should be my answer. Alright, I'm going to stop this video and continue on 42C on the next video.